Okay, this is number 2 on the part where you weren't allowed to use the graphing calculator. And it's the same thing. Get the domain, get the vertical asymptotes or points of discontinuity, horizontal or slant asymptotes, x and y intercepts, and then graph it. So there's the equation there. The domain. Well, the domain, just like the previous problem, the domain, I'm going to set x plus 3 equal to 0, and I get x does not equal negative 3. The vertical asymptotes is where the denominator equals 0, or that's where the point of discontinuity is if it's cancelled out. Well, in this particular case, this doesn't look like much of a 3, so I'll redraw that. It's basically the same thing up there with an equal sign. So I can draw that in. So it's going to go right there. Something right there. There's the vertical asymptote. And then I'm going to also get the horizontal one. It turns out the degree of the top is 1, and the degree of the bottom is going to be x squared, so that's y equals 0. So that's a horizontal one. And top y equals 0 is smaller than bottom in powers. So there we go, and that's going to look like this. It's this axis right here, the x-axis. Okay, and then we're supposed to get the x-intercepts. I'll do that over here onto the right. The x-intercepts is where y equals 0. So in order for that to be 0, that's going to happen. That's only going to happen when the numerator is equal to 0, when x equals 0. Okay, so x equals 0, so when x equals 0, y equals 0. And the y-intercept turns out to be the same numbers as that, but that's where x equals 0. And if you were to actually calculate it, x equals 0 on top, y, and then on the bottom it's going to be 3 squared, which is still going to be 0. And like I said, you're going to get this coordinate here. So let's graph that one there in purple. So that's going to be right here. So there, we've got that there. We've got those graphed. Now, we've got to think about what's going on here. Okay, what caused this part to be here? Well, it's when this was set to 0, and that had a multiplicity or a power of 1. And a power of 1 for zeros means it's tangent. So this is, I'm sorry, excuse me, it doesn't mean it's tangent, it crosses the x-axis. So we know that this point here, the line is going to cross the asymptote near, and that's pretty much near this area here. So that's okay. We're not near the end, so that's okay. We just have to figure out where we come from, the top or the bottom. Okay. So I'm not sure about that, so what I'll do is I'll pick a point. And a nice easy point to put in here might be something like -1 here. Let's put -1 in here and see what happens. So if I put -1 in here, this becomes -1 on top. And the bottom becomes -1 plus 3 is 2. And then I have to square it. And 2 squared is 4, so it's -1/4. So I'm going to do -1, -1/4, which is just below, right, whoops, it's hard to see it there. It's right there. Well, that's just below, and if I got to cross this thing, it's going to go like this. Okay, so it's going to cross, but I can't. I'm going to bend down here, and then if it's crossing, it's going to have to be asymptotic. Now you can pick some more numbers to see how quickly it goes there, but you got the feel for that. You crossed the x-axis, okay, at the 0, and then we looked at, well, how do we know where the other side? How do we know where this side here comes from? Okay, how do we know what comes from there? Well, I'm going to look at the multiplicity. And what caused this vertical one? What caused that one? Well, that was the bottom here. And it has a multiplicity of 2, which is an even number. And so that means it has to come from the same direction as the other side of it. So this side came from the bottom. So on the other side of the vertical asymptote, it also has to come from the bottom. And I don't have any more x-intercepts, so it's not going to cross anything. It's just going to come like this. And there I've graphed this thing. It can't cross because there's no other x-intercepts. There we go. There's number 2.